Good morning and good afternoon, everyone. Thanks for joining our Cognitive Systems Institute Group Speaker Series. This is Diane Podell. I'm happy this morning to introduce our presenter, Tom Davenport. Tom is the President's Distinguished Professor of Information Technology and Management at Babson College. He's also the co-founder of the International Institute for Analytics, a fellow of the MIT Center for Digital Business, and a senior advisor to Deloitte Analytics. He teaches analytics and big data in executive programs at Babson, Harvard Business School, MIT Sloan School, and Boston University. Most of you probably know Tom for his well-known concept of competing on analytics and his popular Harvard Business Review article and his book by that same name. His most recent book is Big Data at Work, and he's working on a new book that's going to be available early this year called Humans Need Apply, Only Humans Need Apply, Winners and Losers in the Age of Smart Machines. And he's also written or edited 16 other books and over 100 articles, and he writes a regular article for the Wall Street Journal's Corporate Technology section. So let me ask all the participants to please put their lines on mute by pressing *1, not you, Tom. And let me turn it over to Tom to present this morning. Thank you, Tom.
Thanks, Diane. Happy to be here and happy to talk with you about this topic. I know I've not been able to join one of these yet, but I look at the topics, and some are quite technical and some are a little bit more sort of business-oriented. This certainly falls into the latter category, and it resulted from my work during my work in analytics. I came across a lot of organizations using machine learning and various forms of neural networks, and I got quite interested in, what does this mean for all of us humans? And so for the last year and a half or so, I have been studying that issue. Suggested have a book coming out in April, I think, from HarperCollins called Only Humans Need Apply, which I'll show you the cover of it at the end anyway.
Let me just ask everyone to mute their lines. Please mute your lines. There's some noise in the background. And if we don't end that, Tom, I can mute everybody and have you come off of mute.
Okay. So you may have seen that a number of people much smarter than I are very concerned about what it means for people. Bill Gates saying he was concerned about superintelligence, Stephen Hawking, Elon Musk, whom I don't quote here, but he contributed $10 million to study the subject. Bob Shiller, the Nobel Prize winning economist, said that advancing machine intelligence is the most important problem facing the world today, and I tend to trust him because he was about the only economist who predicted the financial crisis. And then a couple of guys out of Silicon Valley, Michael Malone, a journalist, and Bill David, a venture capitalist, wrote in the Harvard Business Review, we will soon be looking at hordes of citizens of zero economic value, which sort of concentrates the mind, I think, to try to think about, what might this do to and for people going forward. And so, obviously, if we look out on what's going on with Watson and other related technologies, there are a lot of reasons why we might want to automate human work. It's some of it is quite tedious. Humans are expensive and getting more so all the time. I think in a lot of the cases where Watson has been applied, for example, this is true in the programmatic ad buying area and marketing and a variety of other contexts. There's just too much data for humans to possibly digest in a reasonable time. I think from the very early days of AI, organizations were concerned with the need for accurate decisions, so you had applications of things like expert systems and rule-based systems in insurance companies and credit card organizations and so on. Now, of course, we have a whole variety of powerful technologies. By the logo, I'm obviously suggesting that Watson is one of them. As I will say later, I think they're really the whole family of cognitive technologies that we need to be adopting these days. Those are reasons for automation, but I think it's fair to say that automation is somewhat problematic, not only because it puts people out of work, and even in those past cases where we had industrial revolutions, many economists will correctly point out that the jobs came back, and they were, in many cases, better jobs than before, but it took a while, and as some other economists, I think Larry Summers has pointed out, there is no God-given assurance that that will happen every time. I think it's fair to say that in many cases humans prefer to be served by humans, and so, you know, we've all been on automated voicemail lines and as some TV commercials illustrate, desperately yell, agent, representative, you know, pressing 0, just because automation has not lived up to its potential in many service contexts. Automation as a business strategy is often a race to the bottom in the sense that if everybody in an industry automates everything, prices fall of the goods and services that are produced, and the margins fall as well, and nobody has much of an incentive to innovate. And there's this other problem that automation typically takes a lot of investment of time and energy in a particular business process, and it's often quite difficult to combine it with creative renewal of a process or frequent innovation in a product or process. So there are some challenges, I think, with automation that might make us look for perhaps some alternative ways of thinking about how do we combine smart machines with smart humans. I think now
Tom, excuse me.
Yes.
Tom, excuse me. I'm gonna mute all the lines. If you can just come off of mute by pressing *1 any time now and say something. Okay, I'm going to have to unmute everybody again. Tom, I couldn't hear you. Did *1 not work?
I'm sorry, I didn't. Did you tell me that I pressed a certain key sequence to unmute myself? Or?
Yeah, hang on a second. Let me mute all the lines. And then, Tom, if you can just unmute your line by pressing *1.
How's that?
That's great. Thank you.
Okay. So, you know, this is not the first automation rodeo we have faced, and obviously in the 18th and 19th centuries we had mechanical systems replacing manual labor. In the 20th century we had administrative and service jobs like bank tellers and airline reservations clerks and so on being replaced by transactional computers. There was always a feeling, though, that we could retreat to higher ground. The higher ground is basically knowledge work jobs that many might argue are threatened in the 21st century. So there is, I think, a certain logic to the fact that these current cognitive capabilities might be quite threatening to knowledge workers who have always been viewed as, you know, having the best possible jobs. So my answer to this knowledge workers being threatened question is yes and no. Automation typically works not by replacing entire jobs, but by substituting for specific tasks, and I think it's certainly true that many knowledge work job tasks will be automated. It's probably the case that some knowledge workers will lose their jobs, which will, you know, depress hiring and lead to unemployment, at least on the margins. You know, maybe we'll have 8 lawyers where there were once 10. When I say this, you don't tend to hear a lot of wailing in the audience that we might have fewer lawyers someday. There will certainly be still a lot of jobs, and I think no one knows how many, and don't be fooled by any fallacies of misplaced precision about how many jobs will be automated or will be created, but there will certainly be many jobs working alongside smart machines, which I will talk about further. We will, of course, have a lot of productivity gains from the use of these technologies, and we could fund all sorts of retraining and redeployment of people. We could fund guaranteed jobs, guaranteed incomes, et cetera, although I think in many countries in the world today we're not feeling particularly charitable, and it might be a struggle politically for us to accomplish that. But I think even though there are some reasons for optimism, workers can afford to be complacent, and if you are not willing to change the way you work and work alongside these machines, chances are pretty good you're not going to have a terribly bright occupational future. So we have to get people concerned about this, but I think the idea of massive unemployment is rather unlikely. So just some examples of this. I used to say 10 automatable knowledge work jobs, but to be consistent with the task approach, I think it's fair to say that every one of these jobs has tasks that could easily be replaced and are being replaced already by some sort of cognitive-oriented system. So teachers and professors, of course, there's this idea of a lot of content being online, and we have these adaptive learning tools that figure out what learners learn best and can serve up content in an intelligent fashion. In law, we have e-discovery and predictive coding that automates document review. Accountants, one accounting firm has signed a big deal with Watson to do automated audits. Tax, of course, one could argue it's been automated at the personal level to some degree by things like TurboTax. Radiologists, we have these machines that can identify cancerous lesions in mammograms and prostate exams and colonoscopies and so on, just by putting little brackets around. And so far that hasn't displaced any radiologists, I don't think, but it's probably limited their growth to some degree. You probably all know about automated story writing at places like the Associated Press. Marketers, more and more marketing activities, like I mentioned, programmatic buying, various other things are being automated in that area. We know about robo-advisors and financial advice, financial asset management, of course, increasingly automated, not much stock or bond trading by humans anymore, as you can see if you ever visited New York Stock Exchange. And Watson, of course, is being applied to pharmaceutical drug discovery. So these are, I think, the pinnacle of jobs, and aspects of them are clearly being automated and have already been automated in some cases. Now, the technologies, I think, are quite diverse here, and I know there are some people who argue that cognitive technologies are very clearly defined, and you're either in that category or you're not. But maybe I'm old enough to have seen a lot of these technologies in the past. I was just reading this morning that machine learning and neural networks were both initially identified in 1957, and in part by Marvin Minsky, who recently passed away. So these things have been around for a while. I really view cognitive technologies as a sort of straightforward extension of the work that many organizations are doing in analytics. Deep learning, of course, is just another version of neural networks. Rule engines, which nobody talks about anymore, but we're still quite successful in many business applications. We have all these kind of variations on workflow to sort of move things along. And as anybody will tell you who works with Watson now, Watson has become quite an amazing collection of capabilities that encompass a whole variety of these areas. And I think what IBM is doing, what some other companies in the cognitive space are doing, like Cognitive Scale, is really creating these custom integrations and combinations, some of which will be prepared by a vendor, some of which will be sort of do-it-yourself by a user or a user working with a consultant or whatever. I actually wrote a little piece about this with my co-author for the book and MIT Sloan Management Review about just how smart are smart machines, and sort of in what cases do they totally replace humans, and in what cases are they still augmenting humans. And, you know, we go back to a level of intelligence that I call human support, which is certainly the idea behind analytics. You know, we prepare a model, we do some analysis, and we present that to a decision maker to make a decision in many cases. Now, in many cases, the decision maker didn't actually use that model, and that was part of the problem. So we get into repetitive task automation, context awareness and learning, which I think we can say the smartest technologies are capable of today, and then really self-aware intelligence, which, you know, I guess you could define that as the singularity in a way. We're clearly not there yet in any of the task types that I talk about here, whether you're talking about analyzing numbers or words and images or performing digital tasks or physical tasks. And note on the far right, there's sort of great convergence where as we get more and more intelligence, the task types start to merge a little bit. So, you know, you may be aware of the fact that Watson has been downloaded into various types of robots, for example. So we'll probably see the combination of some of these categories in that context. The machine learning can work with numbers. We can convert the words and images to numbers, and so they start to look very similar. So I think over time these categories all start to blend together, although again we're not entirely there yet. So what does all this mean for people? I think it's quite likely, and this is sort of the premise of my book, that augmentation is a much more probable phenomenon than pure automation, where smart humans are helping smart machines and vice versa. People do this by helping automated systems do things that they're better at humans at doing, or by focusing on tasks at which humans are still better, and there certainly are some of those. We talk about a lot of them in our book. Fortunately, you know, my son, for example, is a TV comedy writer, and there are computers that write comedy, but they're even less funny than humans who are writing comedy. Although I sometimes suspect that Saturday Night Live must be written by computer because it's not very funny anymore. The classic augmentation example, of course, several people have written about this, mostly economists, is freestyle chess, where humans working with a variety of machines are better than either humans alone or machines working alone. And, you know, that may not always continue, but I think there will be a lot of contexts in which this is the case. And in a way, we've seen it before. People who were good at, you know, installing, configuring, improving textile machinery never lost their jobs. And in fact, if there had been more of those, Jim Besson at Boston University argues the Industrial Revolution would have been much more productive much more quickly if we'd had more people who understood how these textile machines worked. And the same is true with spreadsheets. You know, we thought maybe, well, spreadsheets will eliminate accountants and financial planners, and no, I'm not sure it's put a single one out of work. It just means they all do many more analyses with the greater productivity of spreadsheets than they did before. So the core of our argument in this book is really that there are 5 ways that humans can step in terms of working with smart machines or working alongside them. Stepping in is kind of the core of augmentation, where humans master the details of the system, how it works, how it needs to be improved, and so on. Stepping up is kind of taking the big picture perspective and looking, you know, maybe think of a hedge fund manager where all the trading is done via automated systems, but the hedge fund manager is sort of constantly looking at, well, you know, do we need better systems? Do we need to improve the logic of the systems that we have, and so on? Stepping aside is when humans do things they do better than computers, at least at the moment. You have to sort of step lively if you're doing that, because computers are getting better all the time at various tasks. Stepping narrowly is choosing something that is so narrow that it just wouldn't be economical for somebody to automate. I first encountered that idea. I saw a big article in the Boston Globe about Dunkin' Donuts franchise brokers, and I thought, that could clearly be automated. Connecting buyers and sellers is something that computers really do well, but it's probably not economical to do it in that context. And since then have discovered a whole variety of people who are unlikely to be automated anytime soon. And then, you have people who just build automated systems in the future. So, IBM keeps hiring 2,000 people for Watson Health and 2,000 people for Watson Consulting and so on. Building these systems, marketing them, implementing them in customer organizations is going to require a lot of people, perhaps not enough to replace everybody who gets laid off. So I won't go into this, but I have an example here in teaching. A friend of mine, Zeynep Tone, who's now at MIT. There are things that teachers will do going forward, and some we profile some in the book in the School of One oriented school in New York City who are clearly stepping in, but there's some people who teach social and emotional growth and leadership and so on. That's hard to do with a computer these days. Or maybe you are a real expert on distressed real estate in a business school, and that may not be economical to automate. And then, of course, a lot of people are building ed tech systems that help to automate some of these processes. So I think augmentation is likely to prevail in a whole variety of these circumstances where there are knowledge bottlenecks, need for a lot of decision quality and consistency, where we have too much data for humans to analyze, and where cognition is too expensive. I give one example here with oncology, and I've done a fair amount of work recently looking at what's going on at MD Anderson and Memorial Sloan Kettering and various places that are using Watson for oncology. Everybody says it's great, but the fact is it's not easy. And Dr. Mark Chris at Memorial Sloan Kettering said, oh, by the way, most of the stuff that we would like to put in Watson doesn't exist yet in a corpus. There's so much changing so rapidly in cancer treatment these days that we have to educate Watson in other ways. And of course, I think oncologists will still go on. There's a fair amount of evidence that humans don't like to get bad news from a machine. Good news they are typically okay with, but bad news they like to get from humans, and oncology is often about bad news. So I think there are plenty of things that humans will be able to do here, even though I think it will certainly change that field. So I have a couple of pages here on implications for organizations and for government and education. But mostly I think it's really important for us to get moving rapidly in these areas, understand how humans will end up working with smart machines. I think many knowledge workers are quite positive about the idea of augmentation, less so, as you might imagine, about full automation. And those knowledge workers who do apply themselves and learn how these machines work and how they can make them better and make the business process better and so on, I think will have a very bright future. Those who don't, I think, have something to worry about. With that, I'll stop, and Diane, if anybody has any questions, happy to answer them.
Thank you, Tom. Perfect timing. Let me ask the audience to come off mute to ask questions of Tom. Press *1.
Here's our book, by the way, coming out in Harvard.
Jim here. Quick question for you, Tom. Fascinating, first of all. Thanks so much. Just fabulous, and I'll get the book as soon as it's out. The point that you started making about the franchise ownership, do you think that cognitive assistants, cognitive mediators, I sometimes prefer the term cognitive mediator, cognitive assistant, do you think they will allow entrepreneurs maybe to have multiple startups parallel and multiple franchises? Is that a direction that you explore at all?
Well, no. Not, my sense is that even a good cognitive assistant will have some difficulty learning a business domain all by itself. I think there will always be some overhead at learning a new business domain, and there may well be some business domains that are sufficiently narrow that it's not worth the trouble to train them. I could be wrong.
Maybe I asked the question wrong. So I know people who are out here in Silicon Valley who are on like 6 boards of a company simultaneously. So they're advising and running boards. I also know some entrepreneurs that have, that are CEOs of 2 or 3 companies simultaneously. Do you think that people's ability could be augmented by these systems to manage more effectively more things or not?
Well, it's interesting. There was a World Economic Forum survey recently suggesting that of the people who took that survey, they don't go into a whole lot of detail, but I assume it's kind of executives and experts that I think it was 30 or 40% expected that there would be automated board members by 2025. So that suggests that you may be onto something. My sense is that kind of big picture understanding that a board member is supposed to apply or a CEO is supposed to apply is one of the things that thus far cognitive systems are not very good at. They're very good at learning specific domains, but not very good at sort of knowing what they don't know and being open to what they don't know and so on. So I think it'll be very interesting to find that out.
Thank you.
Other questions for Tom? Press *1 to come off of mute.
So I was wondering, what would you consider in the next 20 years is going to be the hot job to have? Just computer science in general, or?
Well, the tricky thing about computer science in general, as Bill Gates noted, is, programming anyway is getting increasingly automated. So I think the best jobs are going to be those that are at the intersection of computer science and statistics and math and so on, and some business domain that the person ends up knowing really well, marketing or real estate or whatever, because the pure computer science tasks, I think computers are going to do those much better than humans do, but that combination, that willingness to look at what automated systems are doing and try to improve upon them, I think really requires that combination of business domain expertise and computational awareness and understanding, if not, really deep computational skills. I think there will be jobs for those people probably over the next 10 years or so. 20, maybe not so many.
Okay, that helps, because I know some people are kind of running towards coding to, if I can talk to computers this way, but then now we have the cognitive era where you can actually talk to a computer in English, so it's kind of like that's not safe either now.
Yeah, so we should study English literature, I guess. So we're very clear in our English language instructions to our code generators.
Tom, thanks for a fascinating presentation. This is Scott McLeod. I posted my question in the text chat. In what ways will cognitive assistants create jobs, and in what industries, and also in what languages? If you have given some thought or have insights into that, please.
You mean like languages relative to English and Japanese and that sort of language, or?
Yes, right.
Yeah, all I know is that non-English languages are still struggling a bit with cognitive tools. I know Watson has some translation capabilities now into things like Japanese and so on, but thus far it's been a bit of an obstacle. The 5 steps that I talked to, I think, are all possibilities for creating jobs in every industry that you can imagine. I think the most likely ones are going to be the ones that are, obviously a little bit more structured in their logic. And you've seen that already in insurance and banking and so on, where the decisions are fairly straightforward. I think law, despite being very slow to change, has a huge amount of potential for improvement in this regard, and medicine would be the other one. 2 big professions where I think there will be lots of opportunity for cognitive assistance and for people who understand how they work. It may transform, I think, the whole specialization area. And in a way, I think general practitioners are better off than specialists in this area, because a lot of the specialist knowledge, I think, can be in systems going forward.
Thank you, Tom, and thank you, audience, for the questions. We're out of time, I'm afraid, but let's continue the discussion on our LinkedIn discussion group. I'll send you the link, Tom, and everybody have a good day. We'll see you next week. Thank you very much, Tom. It was a fascinating presentation.
Thank you. Bye-bye.